Hello again, this video is all about trigonometric ratios. So what are trigonometric ratios? These are actually ratios of the sides of the right triangle. So we have sides A, B, and C. So if A, B, and C are the sides of a right triangle, then the angles opposite these sides are angles A, B, and C respectively. So in a given right triangle, as you can see in the figure above, A, which is actually opposite to angle A. So A is the opposite side of angle A. However, A is adjacent to angle B. So A is adjacent to angle B. Side B is opposite of angle B. However, side B is adjacent to angle A. So, and then C is the opposite side of angle C, where angle C is equivalent to 90 degrees. So the first trigo ratio is sine of an angle, and let's say our angle is theta. So sine of the angle is equal to opposite side of the angle over the hypotenuse. So if we are going to solve for sine of angle A, the opposite side of angle A is side A and the hypotenuse is C. So sine of A is A over C. If we solve for sine of angle B, the opposite side of angle B is side B. And the hypotenuse is C, so sine B is B over C. The next trigo ratio is cosine of theta or cosine of the angle. So cosine of the angle, any angle in a right triangle is equal to adjacent side of the angle over hypotenuse. So for cosine of A, so cosine of the angle A is equal to the adjacent side of A, which is side B, A, and over the hypotenuse. So we have B over C. If we solve for cosine of B, the adjacent side of angle B is side A and over the hypotenuse. So cosine B is A over C. Next is tangent of the angle, or let's say the angle is theta. So tangent of theta. Tangent is equal to opposite side of an angle over the adjacent side of an angle. So we have tangent of A, angle A. So the opposite side of A is side A, and the adjacent side of A is side B. So thus, tangent A is A over B. For tangent of B, the opposite side of B is side B, and the adjacent side of B is side A. So therefore, tangent of B is B over A. Next is cosecant of an angle. So, or cosecant of theta. So cosecant of an angle is equal to hypotenuse over the opposite side of an angle. So for the cosecant of angle A, so it is equivalent to the hypotenuse, which is C, and the side opposite of A is side A. So we have C over A. For cosecant of B, so the hypotenuse is C and the opposite side of B is side B. So therefore, cosecant of B is C over B. Next is secant of an angle. So secant of an angle is equal to hypotenuse over the adjacent side of an angle. So for secant of angle A, so the hypotenuse is C and the adjacent side of angle A is side B. So thus, secant of A is C over B. Secant of B is equal to the hypotenuse over its adjacent side, which is side A. So therefore, secant of B is C over A. Then we have cotangent of the angle theta, or cotangent of any angle is equal to adjacent side of an angle over the opposite side of an angle. So uh, cotangent of angle A is equal to the adjacent side of A, which is B, and the opposite over the opposite side of A, which is side A. So therefore, cotangent of A is B over A. Then cotangent of B equals adjacent side of B, which is side A, and the opposite side of B is side B. So therefore, cotangent of B, angle B, is equal to A over B. Now, to summarize the six trigonometric ratios, we have sine, which is over opposite side of an angle over the hypotenuse. Cosine, adjacent side of an angle over the hypotenuse. Tangent of an angle is equal to the opposite side of an angle over the adjacent side of an angle. And cosecant of an angle equals cos hypotenuse over the opposite side of an angle. Secant of an angle is equal to hypotenuse over the adjacent side of an angle. And cotangent of an angle equals adjacent side of an angle over the opposite side of an angle. So the first three, sine, cosine, and tangent, so to help you remember, there is a shortcut. No? SOHCAHTOA. So what is SOHCAHTOA? S represents sine, O represents opposite side, and H represents hypotenuse. C here represents cosine, A is adjacent, and H is hypotenuse. T represents tangent, and O represents opposite side, and A is the adjacent side. So that's the first three, sine, cosine, and tangent. For the next three, cosecant, secant, and cotangent, we have choshakao. So it sounds like Chinese, not choshakao. So cho means cosecant, hypotenuse over opposite side. Sa is secant, hypotenuse over adjacent side. And cow is cotangent, adjacent side over opposite side. Now let's solve the six trigonometric ratios of a given right triangle. So for example, if is equal to 3, B is 4, find the six trigonometric ratios of angle A. So given this right triangle, so angle A is here. So, and A is 3, B is 4. So since we only have two sides, to solve for the third side, we use the Pythagorean theorem, and C equals 5. So let us now solve the six trigonometric ratios of angle A. So for sine of A, so opposite over the hypotenuse, so we have 3 over 5. Cosine of A, adjacent over the hypotenuse, so we have 4 over 5. Tangent is opposite over the adjacent side, so we have 3 over 4. Cosecant is hypotenuse over the opposite side. So we have 5 over 3. Second is hypotenuse over the adjacent side. So we have 5 over 4. Then cotangent is adjacent over the opposite side. So we have 4 over 3. Now, how about if we solve for angle B? So we use the same given, so the same triangle, but this time we will be solving for angle B. So sine of B, so the opposite side is now 4, the adjacent side is 3, and C is the hypotenuse. So sine of B is 4 over 5. Cosine of B is 3 over 5. Tangent of B is 4 over 3. Cosecant of B is 5 over 4. Secant of B is 5 over 3. And cotangent of B is 3 over 4. So next is find the six trigonometric ratios of theta given this right triangle. So we have theta is here. Then we have the adjacent side of theta is 5 and the hypotenuse is 9. So we have one missing side. So we need to solve for the third side so that we can solve for the six trigonometric ratios. So we are going to solve for the opposite side of the angle theta. So we can denote that as x. So using the Pythagorean theorem, x squared is equivalent to 9 squared minus 5 squared. So x equals 2 square root of 14. So solving for the six trigonometric ratios, we start with sine, opposite over the hypotenuse. So 2 square root of 14 over 9. Cosine of theta is adjacent over hypotenuse. So 5 over 9. Tangent of theta is 2 over 2 square root of 14 over 5. Then cosecant of theta is hypotenuse over opposite side of theta. That is 9 over 2 square root of 14. So you can actually uh, simplify this by removing the radical sign in the denominator. So by multiplying both numerator and denominator by square root of 14, and then you can simplify. So we'll just leave that as is. So next is secant of theta, which is equal to hypotenuse over adjacent side of theta, which is 9 over 5. And cotangent of theta is adjacent side of theta over opposite side of theta, which is 5 over 2 square root of 14. Next, we have this right triangle given the angle theta and the side opposite the angle theta, which is 5, and hypotenuse, which is 13. So we are going to solve for the adjacent side of theta, and let us denote that as x. So solving for x using the Pythagorean theorem, x squared equals 13 squared minus 5 squared, so x equals 12. So sine of the angle theta, so opposite over hypotenuse, so we have 5 over 13. Cosine of theta is adjacent over hypotenuse, we have 12 over 13. Then tangent of theta is opposite over adjacent of the angle, so that we have 5 over 12. Cosecant of theta, hypotenuse over opposite side of theta, 13 over 5. Secant of theta is hypotenuse over adjacent side of theta, which is 13 over 12. And lastly, cotangent of theta, adjacent side of the angle over the opposite side of theta equals 12 over 5.